Some months ago, I casually started to play chess and fell in love with the game. A few times later, Netflix released the Queen's Gambit series, and now the game is living a new life, with millions of new players on all the major online platforms. So, Eric and I had the idea of challenging ourselves by creating a VR chess game using Unity. The development includes many compelling arguments, like implementing pieces rules, the AI of the enemy bot, networking, etc. Let us know if you find these topics interesting, and we will try to cover them in the following episodes. Even if you are not chess passionate, I'm sure you will find something useful also for your projects. Let's go! We started by downloading some 3D assets from GITHUB. Creating the environment is not a priority when you begin prototyping a project, but we don't want to record empty scenes in our video. We added a table and a stool, bed harmon and 2 particles. With the help of the bloom post-process, we achieve a good magical scenario. Of the chess 3D model, we used only the pieces since we generated our game board programmatically. We extracted them from the model and created single prefabs. We created a procedural script called GenerateBoard, capable of spawning a board of X by Y by Z elements. Each cycle, we spawn a game object took from a list named toSpawn, and by modifying the index that we use to pick an element from the list, we achieve different patterns. If we randomly modify the index, we obtain a random pattern. If we modify each row, we alternate the result. And if we update the index gradually each cycle, we obtain a chess pattern. The chessboard is A by 1 by A elements and has prefabs. We use cubes. An important aspect is that when you position yourself in front of a chessboard, the bottom left corner is black and the bottom right corner is white. This is easily achievable by simply placing in the right order the game objects in the spawn list. We also spawned the board in a custom transform and made some calculation to create a parent with the pivot positioned at the board's center. You can choose if you want the pivot at the spawn origin or the center by flagging a script's boolean. The script is easily extendable and adaptable to many scenarios. At the moment it works with elements of the same size. It could be interesting to transform it into an editor tool and make it work regardless to the item dimensions. It's available on our GitHub if you need it. With the board on the table, we needed a way to place the right pieces on the right squares on startup. We wanted an agnostic solution to utilize this not only for chess and in combination with the procedural GenerateBoard script. We ended up attaching a script to the board's elements, and each time we spawn one of them, we populate a script's variable with a unique string composed of its index coordinates. For example, the black square in the bottom left corner is 0, 0, 0. And the black square in the upper right corner is 707. With this setup in place, we just needed to assign each board pieces the corresponding coordinate and find a match. We did this inside a script called Chess Manager. In a further phase, we will adapt the naming convention to the real one, which wants numbers to identify rows and letters to identify columns. Since this is a VR game, and we want to target the Oculus headsets, the next step was to install the Oculus integration package and switch the project to Android. If you are interested to learn more about how we develop the hand tracking and drag and drop features, be sure to check the video A Hand Tracking Experiment with Unity. I can guarantee you that picking up chess pieces with the hands is really satisfying. Also, I find this use case very suitable for a VR experience. I'm not particularly eager to play 3D chess games from a PC or mobile, since the perspective is uncomfortable. You don't feel and perceive the depth, so playing games like that in 2D is 100 times better. Playing it in VR is a solution. I would like to have a real opponent in front of me. Let's now see how we implemented some fundamentals mechanics. In our hand controller script, we retrieve information about our hand's state. We see if they are triggering with a collider and grabbing or releasing an object. To share these states across the project, we use scriptable objects. We can use scriptable objects to create a communication layer across the project. The implementation is simple. You need a class that inherits from scriptable object and exposes a Unity action and a method to raise it. Now you can create an asset and reference it wherever you need. The handController class references a scriptable object of type saysPieceEventSO. When a trigger occurs, it uses it to raise an event informing all the subscribers about the piece touched. For example, the chess manager script subscribes to the event and uses the information it receives to switch material to the touched piece. Other mechanics we implemented in a similar way are about the grabbing mechanic. When we grab, we propagate an event containing the piece data. The manager listens to this information and reacts by highlighting the free squares and raycasting from the active piece to find which square is below. If the square is free and eligible, we position the piece on it. If it is occupied or our active piece is over a not allowed position, we return the piece to its original position. If you want to learn more about using scriptable objects in your project, we can advise you on many good tutorials and videos. Come to say hi in our Discord server. This is the end of the first episode about creating a chess game. What do you want to see in the next one? I found an interesting topic implementing specific rules for pieces like their movement, check and checkmate. Let us know in the comment below if you want to see more. If you liked the video, don't forget to help us by subscribing to the channel and sharing a word about TNTC with your friends. Thanks a lot, see you in the next video, bye!